121, 123, Obafemi Awolowo Way, Okeado, Ibadan. On this note, I welcome you all to another class, to another interesting and educative physics class. I am SHEU AZEEZ, your regular host on this program, Class on Air Physics. Today, we are still moving on to measurements and instruments. And when we are talking about measurement and instruments, I think I've done the introduction last week. It's just a continuation of the same kind. Now, and I give example that a very good measurement has to consist of a numerical value and units. And I made mention of example like 5 meter, 2.5 kilogram, 30 seconds, 25 degrees Celsius. And last week, a student calling to ask about the definition of measurements. Let me still repeat. Nobody will ask you in physics the definition of physics, the definition of measurement. It's just like mathematics. When your teacher is on air to teach you logarithm, so the first thing he started with is definition of logarithm. So, but in the exam, nobody will ask you what is logarithm, but the only thing is just that you have to apply it with that definition. So now we go to the old system and new system of measurements of physical quantities. After that, we went on to laboratory equipment and their uses, like meter rule to measure distance and up to a meter according to its name, tape rule to measure length along a curve or long distances. So we have vernier calipers to measure external and internal diameter of a tube, and it can be used to measure a depth too of a tube. We discussed about micrometer screw gauge, burettes, stroke pipettes, balances, chemical balance, beam balance, lever balance, direct reading balance to measure mass, stopwatch, stop clock, sound clock, ticker timer, spring balance to measure weight, photometer to measure light intensity, hygrometer relative humidity, barometer atmospheric pressure, hydrometer relative density. And we move on to errors. We gave the definition of errors as different between the measured value and the true value of a physical quantity. That means to get an error, mathematically we can say measured value, you take away the true value. So in most cases, the measured value is usually bigger than true value. But in rare case, we can have true value being bigger than measured value. So we go ahead to types of error with examples there. So I talk about systematic errors. So that means error that is due to faulty instrument. Random error. So this one, the observer has no control over it. We have parallax error. So looking at the calibrated scale at an angle, you are going to commit parallax error. Gross error, that means the error that the observer is taking a value and recording another value in the entirety. So that's gross error. So now we move on to accuracy and precision. So and then I give the comparison as accuracy, how the measure value is close. Now from there we move on to measurement of length. So and then we talk about meter rule, tape rule, calipers, vernier calipers, micrometer, screw gauge. Now and then I promise that today we are going to work on vernier calipers and micrometer, screw gauge. And I gave an assignment that you should go and study the diagram of a vernier caliper and as well a micrometer, screw gauge. Now let's now move on in today's class now, which is the continuation of our last class. So we are going to micrometer, screw gauge. Let's first of all discuss about the future of micrometer, screw gauge. So we have a ratchet, or we call it a stopper. So we have a thimble. So that around the thimble we have a scale calibrated around that thimble, and then we call it a circular scale, and in some instance you can call it vernier scale. And we have the sleeve or barrel. So this one we have calibration there too. We call it a main scale. And then in that main scale we have the upper scale, and then we have the lower scale, and then we have the nut, we have the frame, we have the spindle, and we have the anvil. So spindle and anvil is the position where the object you have to measure can be in between, and then that one is movable. The spindle is movable while the anvil is fixed. Now if you want to measure any instrument, any object, you put it between the spindle and anvil, and you continue to tighten the thimble. So when you get to a stage so that the object will not be able to deform, so you hold on to the ratchet, and after a click you stop tightening the instrument. So and then you now take your main scale reading and your vernier scale reading. Let's now go to how we can use it to take reading. So now let's go to how we can use it to take reading. Measurements using micrometer, screw gauge. You are welcome back. You are still on Oxygen 96.9 FM. The station that inform, the station that inspire, and the station that ignites. Now we are not going to how we can use micrometer screw gauge to take measurements. We have two readings. As I was explaining before, we have the one on the sleeve. We call it main scale reading. And we have another one on thimble, so which is called vernier scale reading. So now, vernier scale reading is measured to precision of hundredths. So now, automatically, when we get our main scale reading, so you record it raw like that, you will now add it to the vernier scale reading. And how are you going to get the vernier scale reading? What is on the thimble? So you are going to multiply it by the least count. The least count is over 100. So that means 1 over 100. So automatically, for example, let's say on the vernier scale or on the thimble, we have 30. So that means it will be 30 divided by 100. And you are going to have 0.30. So, mind you, micrometer screw gauge is usually calibrated in millimeter. So let's now go to step by step on how we are going to do this. So let's assume that we try to read the sleeve scale. So you note the feasible scale, the last feasible scale mark on the sleeve just before the thimble edge. So let's assume that we have 5. That means the upper scale. But there are still lower scale. Those lower scale, they are half of the upper scale. Let's say we now see 5. After 5, you now see another 1 lower scale. That means it will now be 5.5 millimeter. So now let's now go to the thimble. So we have, let's say the sleeve coincide with the main scale, the line of the main scale, the line division of the main scale. So maybe the point of coincidence is 28. So you are now going to apply the least count. So that means you are going to multiply that 28 by 1 over 100. So automatically it will now be 28 divided by 100. So which is going to give us 0.28 millimeter. So the final reading now will now be the main scale reading, so which is 5.5 millimeter plus the vernier scale reading, which is 0.28 millimeter, which everything now gives 5.78 millimeter. So now let's now go to a typical example on this. Example on measurement of length using micrometer screw gauge. Now you can see the example there. So let's look at the example there. We have example A and B. So from example A here, we can see that the main scale reading of the micrometer screw gauge is 5, and you can see you can see that there is another what is it called? There is another line after that 5 for the lower scale. So that means the main scale reading there will now be 5.50 millimeter. 5.50 millimeter. So now the vernier scale reading times the least count. So you can see that at 10, the thimble, that means the circular scale, coincide with the main scale. So we have 10. So that means 10 divided by 100. So we now have it to be 0.10 millimeter. So if you add the two together, so that means the reading of the object being placed, being used, that we use the micrometer screw gauge to measure will now be 5.60 millimeter. Let's go to the second example. We have 20 as the last. So we have 22, sorry. So we have 20, 21, 22 as the main scale reading. So that means 22.00 millimeter. And the circular scale, so we have it coincide on 33. So on 33, so 33 divided by 100, 0.33. So now, if you add it together, it will now be 22.33 millimeter. Hello. Okay. Now, vernier calipers. So from the diagram, from the assignment, you can see that the vernier caliper has 2 feet. So we call it jaw. So we have the inside measuring jaw. Hello. Hello.
Hello.
Hello, good morning. Your name, where are you calling? Hello? So now, we have the inside measurement surface and we have outside measurement surface. If you see the inside measurement survey, it is flat outward, and outside measurement surface is flat inward. So that means if you want to measure the diameter of a tube, so you place the inside measuring surface into the tube to measure the internal diameter. So, and the external, you do the opposite. So now we have the slider. We have the vernier graduation. So that means that's where we get our vernier scale reading. So instead of the one that we have circular in a micrometer screw gauge, that means we can still call that one vernier scale reading as well. So we have the thumb grip. That means where you can use your thumb to roll it so that you can make it tight to the object you want to measure it with. So we have the set screw. We have the main scale, where we take your main scale reading. We have, what is it called? The depth bar. The depth bar is the one that you can use to measure the depth standard surface. So now, let's now go to how we can use this particular instrument to measure. So, measurement of length using vernier caliper. So now, the same way we've done for the micrometer screw gauge, we are going to measure the main scale reading. So we are going to add it to the vernier scale reading multiplied by the least count. That means the vernier scale will be multiplied by the least count, and you are going to now add the solution with the main scale reading. So step 1, we are going to note the before I go on. So my vernier caliper is usually calibrated in centimeter. It's just like your ruler. So if you look at the calibration on your ruler very well, the main scale reading of vernier caliper is just like your ruler, exactly like your ruler. So now, the main scale reading. So let's take an example that on the main scale reading we have 2.3. So now say is 2.3 centimeter. We now go to vernier scale reading. So for this vernier scale reading, for the vernier division, you look for where the vernier calibration, the vernier scale calibration coincide with the main scale calibration. So let me come again. So you look for where the vernier scale calibration coincide with, what is the meaning of coincidence? So where the two line reading, which is 0.04 centimeter. So our final reading will now give us 2.34 centimeter. So let's now go to example. We have example 1 and example 2 on that. Two example. The first example, if you look at it very well, you will see that before the vernier scale, so the last point you can see is 1.1 centimeter on the main scale. So you now write it as 1.10 centimeter. And if you now look at the vernier scale, look at it very well, you now see that the line that coincide with the main scale is the line on the 10th line. So that means the vernier scale is 10. So we now make that 10 to divide it by 100, which is equals to 0.10 centimeter. So you now add it to 1.10 centimeter. So it will now give us our final answer there will now be 1.20 centimeter. Let's now go to the second example. So the last scale, the last reading on the main scale there is 2.7. So that means it's 2.70. So you now add it to the vernier scale. This one, the vernier scale coincide. This one we have more than one coincidence. But the first line that coincide with the main scale is the fourth line of the vernier scale. So 4 divided by 100, it will give you 0.04 centimeter. So if you add it to 2.70, it will now give you 2.74 centimeter. Yeah, welcome back again. So this is class on air physics on Oxygen FM 96.9 Okeado, Ibadan. Now let's now go to the next instruments that we use to measure mass. So those are balances. So we have lever balance, we have triple beam balance, or we call it beam balance. So we have chemical balance, we have electronic or direct reading balance. So now, if you look at the lever balance, the lever balance can be used to compare unknown objects against known using pivot bar and central fulcrum. So I think when we get to machine, you still know more about fulcrum or equilibrium. So now, the second one, beam balance. Beam balance, this uses 3 beam with sliding weights for precise mass reading in the laboratory. So now, the next one, we have chemical balance. This is very sensitive and it has 2 sensitive pan balance used for weighing small quantity in chemistry. So it's from there that we derive it as a chemical balance, because majority of what they use it to measure in chemistry is chemical. So we now call it a chemical balance, but it can be used outside the chemistry laboratory. So now let's now go to the fourth one, electronic or direct reading balance. These use a load sensor to display mass directly on a digital screen. So and then if you look at the definition, the description, so you will come to realize that the chemical balance look like if you have seen the law firm logo before, so look like the law firm logo. So it should just be weighing like that, and a known mass, you put it at one side. Your known mass that you want to measure, you put it at the other side. So you will continue to increase your known mass until the chemical balance is being balanced. And when it's balanced, that means that the unknown mass has already equals to known mass. If known mass is 5 grams and it is balanced already, that means the unknown mass, you've known the quantity now. It is now what is it called? It is now 3 grams as well. So now let's now go to electronic balance. Electronic balance, in some contexts, they call it a kitchen scale, because they used to use it in the kitchen for baking and some other things, weighing salt, weighing sugar, weighing flour. So sometimes they call it a kitchen scale, but in physics we call it electronic scale. So we have the beam balance that have 3 they have 3 masses that you can use to adjust and on a scale. So we have lever balance, so that have a pointer. So and then we have direct reading. Direct reading, I don't know if you've gotten to where they used to sell frozen food. So you can see that type of scale they used to use there is called direct scale. That we just put the chicken on top of the scale and you see the pointer moving up and down. So now unless I forgot the definition of mass, we have to define length. Because everything in physics has their own meaning. So you have to know the meaning before you know how to deal with that physical quantity. So for the length is being defined as the measure of gap between 2 positions or between 2 points. So let's now go to mass. Mass is the quantity of matter in a body. So now let's now go to the next type of measurements. Now let's go to measurement of weight. So for measurement of weight, we use spring balance. So you can see that we'll be mentioning balance. But this one is balance too. What's the difference between this and the other one? So this one, because it is measured with respect to the gravitational pull, so it measures weight. So automatically, if you want to know the mass, so it's just for you to divide the answer gotten from this instrument by 10 to get the answer. And what is weight? Weight is the force of gravity acting on a body's mass. It is measured in Newton, and we use spring balance as it was said. So now, and then there are some spring balance that is calibrated in both gram or kilogram and Newton. So I want you to take note of that. That means we can still improvise when there is no spring balance. We can use all other balances to measure. You get the mass, and you now use, that force is mg. weight is mg as well. So that means mass times acceleration due to gravity. And then you know that acceleration of gravity is 10 meter per second square. So now, thank you for being there. So we are going to measurement of time. And what is time? Let's first of all define time. Time is the interval between two events. So now let's take for example between morning and night. Morning is an event and night is another event. So the interval between those two events is called time. So let's take another example of this class. So the time we are starting is an event. When we are starting is an event, and when we are going to stop this class is another event. So that means the interval between those two events is called time. So and then what we can use to measure time, we have the stopwatch. So we have the stop clock. So we have the pendulum clock. We have the ticker timer, as I mentioned the other time. We have digital or atomic clock. So now those are the instruments we can use to measure time. And if you can see, for stopwatch, you can use it in the laboratory, but they use it most in race, in sports. So to know the time the race starts and the time an athlete gets to the finishing point. So now we have a stop clock. That one is most often used in the laboratory. So we have the pendulum clock. So that one is hold, or we call it the regular swing clock. So most of us that still have grandpas are alive now, that they've bought it then and they still have it at home and in some religious places. So you will see it there. So the second hand is the pendulum, so swinging under the clock. So we have the ticker tape timer. So that one is just like a tape. So now and then we have the digital or atomic clock. So now let's now move on to the next one, which is a measurement of volume. So what is volume? This is a measure of amount of space a substance or object occupy. So that one is measured in meter cube or cubic meter. I think we've done that before. So we now have regular object and irregular object. Example of regular object, we have cuboid, we have cube, we have cylinder, we have sphere, we have pyramid, we have prisms. So now all these ones, they are regular objects. If you want to calculate their volume, you use formula directly from your mathematics. So like cuboid now, cuboid is just like a rectangular box. So and then for the volume of that, you have length times breadth times height. And when you talk about cube, you know, cube has all sides are equal, just like keyboard, but the keyboard all sides are not equal. But for the cube, all sides are equal. It's just length times length times length, or side times side times side, which is side cube. So now the cylinder, as you have it in your mathematics, so you have pi r square. For sphere, you have 4/3 pi r square, pi r cube. So now all those ones, they are regular shaped object. So just use formula for it. But let's now go to irregular. If you come to irregular, so for finding that, so we are going to use displacement method. So and with measuring cylinder or overflow can. This overflow can is often called Eureka can. The word Eureka is an ancient Greek word meaning I've found it, or I have discovered it. So now, this is how it happens. How do we come about this? It's discovered by a great scientist called Archimedes. So, and he used that to discover the Archimedes principle. So, the story behind it, there is a king in the ancient Greek called King Ero II of Cyprus. So the king gave some pieces of gold to a goldsmith, to a craftsman, to help him to make a crown. So when the goldsmith brought the crown, the king was in doubt that this man did not use all the pieces of gold given to him. The only thing he does is mix it with some silver and keep the remaining gold with him. So the king is worried and called the great scientist of then, Archimedes, at home. He just discovered that when he just entered the bath, so there is displacement of water in the bath. Now discover that water, water. So now that one, we are still coming back to that when we get to force in fluid. So now, before we are going to round up today, I want to do some assessment. I have some review questions for us. So now I will call the telephone line out so that we can call in and I'll ask my questions. So the first line 070-4700-3969. Again 070-4700-3969. The other line, if that one is not going, 070-4700-2969. 070-4700-2969. So now the first question on my list here. So I have, hello, good morning.
Good morning, sir.
Your name and where you are calling from, and the name of your school either.
My name is Joseph Toran.
Okay, you're welcome. So now, please listen to this question. So,
yes, sir.
Which of the following is derived unit? 1. Kilogram. 2. Meter. Newton. That's good. That's correct.
Yes.
Should I still ask you more?
Yes, sir.
Okay. The second question say the inner diameter of a plumbing pipe at oxygen 96.9 FM Ibadan can be measured accurately using A. Pair of vernier calipers, B. Meter rule, C. Micrometer screw gauge, D. Pair of divider. Meter rule. Let me come again with the question. Or you want to go for 50-50? Let me come again with the question. The inner diameter of 0.9 FM Ibadan can be measured accurately using A. Pair of vernier calipers, B. Gauge, D. Pair of divider.
I don't get the questions.
So that means you are not listening and not getting the line. Is the question too long? And keep exploring the wonderful world of physics. We are going to meet again, same time, same station, next week, by God's willing. And tomorrow, you can still stay tuned for biology on this station. Thank you.